I'm doing a video reassessment for standard 5 numerical calculations. I made up a problem. Someone drops a ball and it takes 4.3 seconds to hit the ground. So I've figured out how high the ball is by taking h1 equals 1/2 times gravity times t squared. We have t, we don't know h, we know gravity. So you just plug in the time that it took. So 4.3 seconds squared times 9.8 meters per second squared times 1/2 gives you 90.6 meters. That's how high the ball is dropped from. And I do a numerical calculation for 10 different heights, and h1 to h10, I get 78.4 meters per h2, h3 67.08 meters, and basically you just keep doing increments of 3 seconds each time the ball is dropping 3 seconds. For every 3 seconds, that's so it starts off at 0 and comes down 3 seconds, and just keep taking off the 3 seconds all the way down the problem to get enough for 10 pieces of information. And you take this height and you can use your height for your change in y over your change in time. So basically what we'd be doing is t1 minus t2 to get 3 seconds, and you just keep doing that all the way through. So v2 equals h1 minus h2 over t1 minus t2. So v2 equals 12.2 meters per second over 0.3 seconds. So v2 equals 40.66 meters, and you just keep doing that all the way to get all the velocities for each height. You just plug in the h2 for v2, h3 for v3, and you subtract your height. Like, so you'd say h3, the height from this 90.6 meters minus 67.08 meters would be the height that I'll need for v3, and you just keep doing that all the way down. So you take your height 8, 23.72 meters minus 90.6 meters for height for the 8th height h8. You plug that in for your v8. So 90.6 meters minus 23.72 meters gives us 66.88 meters over 2.1 seconds, because you take your 4.3 minus your 2.2 gives you 4.3 minus 2.2 equals 2.1. So you use your 2.1 over 66.8 meters to find V8, which is 31.81, and basically just do that all the way down for 10 pieces of information, velocity. And you do the same thing for acceleration. So you have, your velocity from these, and you take your velocity over time, and change in time for each increment is 3 seconds, so it's always going to be 3 seconds. But the change in velocity usually will be the same, so it's so we figured out that it's a constant acceleration all the way down from start to finish. And that's my numerical calculation. I found the height of the ball, and then I found the velocity of the ball for each time, and then I found the acceleration, which I found out that it was constant by working it all the way out.